Okay, now we're going to enter our bend sequence. We're now looking at the base data screen where we've completed the part profile. We have our tooling selected. We now proceed to step data. Once again we see our part profile with all the different bends and endpoints identified numerically. You see we're at step 1, and it's going to ask us what edge are we going to use for the stopper. In other words, what edge will be up against the back gauge, and then we're going to tell it which bend we're going to bend. And we will go step by step here, next and previous step, to identify the bend sequence. Now, this, of course, is based on the premise that you already know what the bend sequence is going to be for this part. So let's go through the sequence, and we can monitor the bend graphically as we progress. So we're going to use 0 as our first point. Fortunately, this graphic, the 0 is hidden behind the 4. 0 always identifies the leading edge on the left. So we're going to say 0 for the reference surface. It is now asking me which bend I want to do. We're going to bend number 3. I have to bend those middle bends first. And if you want to see what it looks like, just touch the screen and you can see what that first profile will look like. We go to next step, and we're going to use, call back the bend profile, we're going to use edge 7 to bend at number 4. Once again, one of the middle ones. Let's just take a look at the progress. That's what it looks like. We can see that we've just got enough room to clear it on the setup. This is the advantage of programming with graphic mode, is that we know in advance whether it's going to work or not. Alright, back to our part profile. We're now going to go to step 3. So next step, step 3, we're going to place our stopper once again at the 0 edge, and we're going to bend angle 1. Our next step, we're going to use angle 1 as our gauging position, and we're going to bend angle 2. Take a look at this if you like. This is what it looks like after end. So we've bent that end of the part. Next step, we're going to use reference surface 7 to bend angle 6. And finally, next step, step 6, we're going to use angle 6 to bend angle 5. We can now press the graphic screen again. There's our final bend. Simply by pressing next step, we can go through the entire sequence where it's back at step 1, or step 1, step 2, 3, oops, excuse me, I pressed previous step, 2, 3, we have a completed bend sequence. You have other data here. These 2 columns, this is for a correction on your flange length. The next row is your angle correction. It's important to note that the column on the left will be a correction for your entire part. It says all correction versus a step correction that will only apply to the angle or to the step that you're currently on. So if we go to step 1, we'll see we have a 3.01 flange, 90-degree angle over 48 inches in length. If we're underbent, we could put in an angle correction just at this step, for example, of plus 2 degrees if we're overbent. Of course, if we're underbent, then we put a negative value in. Just touch the fields. Any of these fields, you simply touch them to call up the keyboard, put your data in, and enter. Your back gauge retract, standard function. Got a back gauge delay, of course. which will delay the positioning of the back gauge to the next bend by the number of seconds you've input here. Upper limit, again, this is to shorten the stroke. If you don't want the ram to go all the way to the top, you simply put a value in. This dimension you put in here will be distance from the top. So if I was to put in a 2-inch upper limit, excuse me, upper limit, we now have a 2-inch upper limit. That means the ram will stop 2 inches from the top of stroke. Speed change point and pinch point have been calculated automatically based on material thickness and the setup we're using. Your bend speed is by default at 100%. You can slow that down infinitely, as well as your return speed is also adjustable. And then you have a bend dwell. You can have the ram pause at the bottom of stroke before returning to top. These other fields here, tonnage. Tonnage is a value has been calculated automatically. It figures that it needs 29 tons to bend this particular flange. Crowning is also calculated automatically. This is a crown that's built into the upper beam by the C-axis or the crowning axis. All these values can be adjusted manually simply by touching the field. You can increase or decrease these values. Ram tilt. Also, if you're not getting a straight angle all the way across, you can choose to input a ram tilt. This is a dimension in inches. Generally, the rule of thumb is about 0.003 of penetration per degree of correction you require. At this point, we have finished programming this part. From here, we can now go to automatic mode. And in automatic mode, we only have to hit start, and the gauge will position itself, and the program will start.